Hello friends. So today we are going to discuss about the concepts of wavefront. That is the basic concepts which we talk about in the chapter of light. And we are going to talk about the basic theory, that is the Huygens principle for the origination of light. So this is all we are going to talk about today. So starting with the concept of wavefront and Huygens principle. What do you mean by wavefront and Huygens principle? Like when we say light is supposed to travel in a form of wave, because when we talk about light, it is considered to be an electromagnetic wave. When I say light is an electromagnetic wave, means what? It consists of two fields, electric field as well as magnetic field. So a wave which is consisting of electric field as well as magnetic field, it is going to be called as electromagnetic wave. And why do I refer light as an electromagnetic wave? Because when we say electromagnetic wave, it has a speed of around 3 into 10 raised to 8 meter per second, which was already calculated previously. And after that, they found out that the speed of light is also same, that is 3 into 10 raised to 8 meter per second. So they were aware with the value of speed of electromagnetic wave. They were even aware of the speed of light traveling through a vacuum. So they considered that whenever we talk about light is going to be considered as an electromagnetic wave, because we are aware that whenever light travels through a medium, it travels in a form of wave. But that's not necessary. Like for some phenomena, light is going to have another property or another nature, that is particle nature. So for some phenomena of light is going to travel in a form of wave, and for some phenomena, light is going to travel in a form of particle nature, or you can say the light is going to exist in a form of particle nature. But right now, whenever we are discussing about wavefront and the basic theory of light, we are going to consider light traveling in a form of wave. Now, before starting with the concept of wavefront, we are going to talk about something that is a natural phenomena about the ripples which we observe in water. Like suppose if I have a still water present, and if we drop a pebble in it, whenever we drop the stone in that still water, the point at which it is going to get dropped, it is going to create disturbance. Means the point at which the stone is getting dropped in the still water, which was completely still without any disturbance, as soon as you drop the pebble in it, it is going to experience disturbance, and the disturbance is going to travel in the outward direction. As you can see in this example, the pebble is dropped at this point, and as soon as the pebble is dropped at that point, there is a energy transferred by the pebble to the water molecules at that particular position. That means what? As soon as I throw the pebble in that still water, I'm the person or I'm the agent who is transferring energy to the pebble, and that energy is traveled by the pebble towards the water. And as soon as the stone is allowed to drop at one particular point in that still water, that energy is transferred by the pebble to the still water. So this is nothing but the energy is being transferred from one agent to another, and ultimately the energy is transferred to the water molecules where the pebble is falling. And at that point, whenever the energy is getting transferred, this energy transferred creates disturbance in the water molecule of the water. That means when we say the water is getting created or the ripples are getting created in it, it is due to the energy provided by the pebbles at that particular point. And if we provide energy to the water molecules at that point, that energy will be gained by the water molecules and they will start vibrating. So any object which is, or any material which is going to gain energy, obviously they have the tendency to vibrate with that energy. So for example, over here the water molecules are gaining energy, and the water molecules are going to gain the energy and they will start vibrating about their mean position. And because of the vibration being produced, we can see the formation of ripples, or you can say the formation of small waves in the outward direction. So the waves are getting originated from a single point of disturbance, that is, this point is behaving as a point of disturbance. I can just denote that point to be A. So A is indicating that is the point of disturbance, and the energy is getting traveled in the outward direction from the point of disturbance, and the energy which is getting traveled in the outward direction, it is traveling in a form of wave. So we have to be very much clear with the concept that whenever we create a disturbance at a point, at that point, whenever a disturbance is created, the energy is going to get traveled in the outward direction. Obviously, the question arises that in which manner the energy is going to travel. So the energy is going to travel in the form of wave. So this is just an example of energy or travel of energy or a propagation of energy when the disturbance is created in the still water with the help of pebble. Now, if you consider an example of leaf which is present on the surface of this water, and as soon as the water molecules are vibrating, the leaf is going to just move up and down. So it is not going to travel anywhere. So the leaf which is present on the water surface, it just has a motion up and down, but not traveling in any particular direction. So when I say the leaf which is present on the surface, it is moving up and down, that means it is due to the vibration of the water molecules below it. So as the water molecules are vibrating below it, the leaves are also vibrating about that particular thing. So that means we can say the motion of the leaf present on the water surface, that is up and down motion of the leaf, is due to the molecules of water which are vibrating below it. So the vibration of the molecules of water is considered to be perpendicular to the direction of propagation of water. So we can say that the molecules of water is vibrating in the direction perpendicular to direction of propagation of water. And whenever we talk about the molecules vibrating in perpendicular direction, that type of wave is termed as transverse wave. So whenever we talk about transverse wave, we say that transverse wave is obtained due to the molecules or particles vibrating in the direction perpendicular to the direction of propagation. So the vibration of the particle is perpendicular to the direction of propagation. That type of wave is considered to be transverse wave. So we can in short say that wave is obtained, or you can say the energy is traveling from one point to another in a form of wave, depending upon in which manner the molecules are vibrating, whether they are vibrating perpendicular to the direction of propagation or whether they are vibrating parallel to the direction of propagation. We can classify the wave into two types, that is transverse wave and longitudinal. But in case of light is a form of energy. So if I say light is a form of energy, if it wants to travel from one point to another, so it is supposed to travel in a form of wave. That is why we say that it is a light wave. Secondly, the particles which are present in the light, they are going to vibrate perpendicular to the direction of propagation of wave. If the vibration of that molecules is perpendicular to the direction of propagation, that means we can consider that whenever light is traveling through a medium, the molecules of the medium are vibrating perpendicular to the direction of propagation. That means we can consider that light is traveling in a form of transverse nature, or we can say that light is a transverse wave. So we can say that light is going to travel in a form of transverse wave. Next is the way we say that the ripples are created in the water, or the ripples created around the point of disturbance, that is nothing but the ripples of water, or you can say the waves which are created by the disturbance created at a single point. This is going to give rise to the small waves, and the small waves are nothing but named as ripple. In a similar manner, instead of using the whole example of disturbance created by the pebble in a still water, we can take an example of a light source. And if I consider a point source of light, that is, if I consider a point source of light, it is going to emit light in all the direction, and light is a form of energy. So as we say that if we consider a point source of light, and that point source of light is going to emit light in the all directions, so this is nothing but, as the light waves are emitted from that particular point source, it is going to create disturbance in the surrounding medium. So when we say that the point source of light is emitting light, that light emitted will create disturbance in the surrounding medium of the source, and that disturbance is going to get traveled in the form of light wave, that is transverse wave. Now when we talk about wavefront, as you can see in this case, we have shown this as the source of light, that is the candle is behaving as a source of light, and the light emitted from that source of light is going to create disturbance in the surrounding medium. This is the surrounding medium. So the light which is getting emitted from that source of light, it is creating disturbance, and that disturbance is nothing but traveling in a form of wave. Now as you can see that we can have a ray of light getting emitted from that source of light. So you have one ray of light moving in this direction, one ray of light moving in this direction. So we have certain rays of light moving or getting emitted from that single source of light, and all the rays of light is moving in a certain direction. We have only considered a certain rays of light which are in forward direction. Now when we say the waves are propagating in the forward direction, they are going to create a wave surface, and that wave surface, like you can see, this is a wave surface created by the wave, this is another wave surface created by the wave, and this is the another wave surface created by the wave. Now the wave surface which are created by the wave is nothing but called as wavefront. So whenever we want to talk about wavefront, these are the wave surfaces which are created by the waves, or you can say these are the waves surfaces which are created by the light waves which are getting emitted from the point source of light. So whenever I consider a point source of light, from that point source of light there is an emission of light waves, and because of the waves which are moving in the forward direction, we get wave surfaces. And when I consider a certain wave surface like this one, in that case we can consider the points on this wave surface, like this 2 point, 3 points, 4 point, fifth point. This all the 5 points are lying on the same wave surface, or you can say the same wave front. So all the points are going to have same phase. That means the points which are lying on the same wave front is going to give me same phase. So we can say that wavefront is formed due to the locus of all the points having the same phase. So whenever we say I consider a locus of points, like locus means group of points which are in same phase, they are going to lead to the formation of wavefront. So if we want to form a wavefront, we need to just consider locus of all the points together, like we have to join all the points together which are in same phase, and whenever we join the points which are in same phase, that is going to give rise to wavefront. So wavefront is simple, that is the locus of points together, and those points which are in same phase, they are only going to give me the wavefront. So wavefront is obtained using the locus of points which are in same phase. So this is the method of obtaining the wavefront. Next is, whenever we talk about the different types of wavefront, we can have different shapes of wavefront. We can have spherical wavefront, we can have cylindrical wavefront, we can have plane wavefront. So we have three types of wavefront which we use commonly, that is spherical wavefront, cylindrical wavefront, and the plane wavefront. Mostly whenever we talk about a single point source of light, so if I consider a single point source of light, it is going to create disturbance in this manner. So in this case, the wavefront which I obtain is a spherical wavefront. So from a single point of source of light, the wavefronts which I'm getting is representing the spherical wavefront. But as we move far away from that source of light, the spherical wavefront is going to become the arc of the wavefront. That means as we move away from the source of light, the only one part, or you can say a certain part of the spherical wavefront is considered, and that represents a plane wavefront. So plane wavefront is not obtained nearer to the point source of light. So if you are nearer to the point source of light, we are going to get a spherical wavefronts. But as we move further away from the point source of light, then we just consider a part of wavefront, or you can say a part of spherical wavefront, which is going to be considered as plane wavefront. So in different manner, like depending upon, suppose if we make use of slit is nothing but a small opening, and instead of using a point source of light, we are making use of slit is going to give rise to cylindrical wavefront. So whenever we talk about the types of wavefront, we can have spherical wavefront, we can have cylindrical wavefront, obviously obtained from different sources, and even we can have plane wavefront. So we can have different wavefronts which is possible. So this is one, that is spherical, second is cylindrical, and the third is plane wavefront. And whenever we talk about the source of this wavefront, they are going to be different. Like whenever we obtaining the wavefront, or the methods of obtaining these three types of wavefront is different. Like if I consider a small point source of light, it is going to give rise to a spherical wavefront. Whenever we consider a slit instead of point source of light, it is going to give me a cylindrical wavefront. And if I take a certain part of a spherical wavefront very much farther away from the point source, that type of wavefront is going to represent plane wavefront. So this is the way we can obtain the wavefronts. Like this arc which I'm getting over here, this arc is nothing but representing the wavefront. So whenever we consider the locus of all the points together which are in same phase, they give rise to the term called as wavefront. Next is the basic important theory which was used for the concept of light, or whenever we studied about the different concepts in light or different phenomena of light. In that, the basic theory which we used was Huygens principle, and this Huygens principle gives you the basic idea about how to form a wavefront. Now when you say wavefront, I said it is nothing but the locus of points which are in same phase. Now what is the theory proposed by Huygens is that every point on the wavefront is going to behave as a source of a spherical wave. That means you can consider, if I have a primary source of light, and from that primary source of light there is an emission of wavefronts, and the point on the primary wavefront is going to behave as a secondary waves. So according to Huygens principle, wherever we consider a primary source of light, for example, I consider the basic primary source. So this point is behaving as primary source of light, and the light which is emitted from this primary source is going to be in a form of waves. So I get a wave over here, and then when we consider different points on this particular wavefront, like 1 point, 2 points, 3 point, 4 point, this all the 4 points are on the wavefront obtained from the primary source. So this 4 points are going to behave as a secondary sources. That means the primary sources are going to emit waves, and the points which we consider on the wavefront of the primary sources, that points are going to behave as secondary sources. So all these 4 points are going to behave as secondary sources of light. So whatever is the basic source of light from where the light is getting originated, that is from this point, it is behaving as a primary source. Now this primary source is nothing but, this is the main source, or this is the main source from where the light is getting originated. Now, after that, you keep on getting waves. These are primary waves. Now, if I consider any point on this primary waves, they are going to behave as a secondary sources of light, because the wavefront, or you can say the light, was initially obtained from the source A. So this is your primary source. But any other point considered on the wavefronts obtained from the primary source, those points are going to be considered as secondary sources of light. So whenever we talk about the Huygens principle, we say that the point on the wavefront, or the point of wavefront, it is going to behave as a sources of spherical wave. Now, in this case, suppose if I consider a single point source of light, and this single point source is going to be a source of a spherical wave. So as you can see, this is what we have drawn, the spherical wave around the point source. So this black dot indicates the point source of light, and this point source of light is emitting, or it is behaving as source of spherical wave. So this is behaving as a spherical wave. Next, this was the original point source of light, and this is the spherical wave which is obtained due to the point source of light. Next, what we have done is, we have again considered 6 more points on the spherical wave. As you can see, they are indicated by the blue dots. So these blue dots are nothing but representing the 6 sources present on the spherical wave. So 6 sources are going to again create this, are nothing but termed as wavelets. So whenever we talk about a single point source of light, like this black dot indicates the single point source of light, it is emitting, or it is giving a source of spherical wave. Now, once I obtain a spherical wave, I consider points on those spherical wave, and those points are going to give rise to wavelets, as you can see in this diagram. As I have 6 sources of point, this points are nothing but indicating the secondary sources. The way I said in the previous slide, that the light coming from the original source is going to behave as a primary source. So the original source is behaving as a primary source. So this black one is indicating or behaving as a primary source. But the other sources which are obtained on the further waves, they are going to behave as secondary sources. So this blue sources are behaving as secondary sources. So the secondary sources are going to give rise to secondary wavelets. So as I have obtained 6 secondary sources from one primary source, so I'm getting 6 wavelets. Now next we have to draw tangents to all this 6 wavelets. So if I consider one wavelet like this, second, third, fourth, fifth, and sixth, and if we try to draw tangent to each and every point, and if we join all the tangents together, we are going to again get a spherical wave. That means I'm continuously getting a spherical wavefront over here. So this is what you say, that if we want to form a spherical wavefront, you have to start from a primary source. We need to get a secondary source, and from that secondary source we can keep on getting many more wavefronts. So this is how the Huygens principle works, that every point on a wavefront behaves as a secondary source of different waves. So the source of light, or you can say the original source of light, is the primary source in the Huygens principle, and as you get any other sources obtained from the further wavefront, they are going to behave as the secondary sources, and you can keep on getting the wavefront in the forward direction. Now when we talk about the plane wavefront, like this is the incident wavefront, this is your incident plane wavefront. So this is, or you can say this line can behave as a primary wavefront. Then what we can say is, we have considered 5 more points on this primary wavefront. as we are aware that this incident wavefront is coming from the primary source. So that is why it is called as the primary wavefront. But when you come to the next point, that is the points which are obtained in the primary wavefront, that is 1, 2, 3, 4, that is 5 points obtained on the primary wavefront. So this incident wavefront is indicating the primary wavefront because it is obtained from the primary source of light, or you can say from the original source of light. Then the points considered on this primary wavefront is going to be considered as secondary sources. So all these 5 green points are indicated, or they can be considered as secondary sources of light. This is according to Huygens principle, that every point on primary wavefront will behave as a secondary sources of light. Next is, when I consider a secondary source of light, it is going to emit a spherical wave, and as I have 5 secondary sources, so we are going to get 5 spherical waves. And if I consider a tangent drawn to each of the spherical wave obtained from each of the secondary sources, and if I draw all the tangents and join all together, we are going to get a new wavefront, that is this one. This wavefront will be called as secondary wavefront because this secondary wavefront is obtained from secondary sources of light, that is this green points. So we can have primary wavefront which are obtained from primary sources of light. We can have secondary wavefronts which are obtained from secondary sources of light. And where are the secondary sources present? Obviously the secondary sources are present on the primary wavefront, that is every point on the primary wavefront acts as secondary sources, and the sources are going to emit wave in a form of a spherical wave. So we get secondary wavefront ultimately. So we can obtain wavefronts in this manner. As you can see that the shape of this wavefront, whenever we join it together, this is indicating the plane wavefront. So this is the method of obtaining the plane wavefront. So using Huygens principle, we are getting, or we are determining the method to find the wavefront. Like for example, if I have a point source of light and that point source of light is emitting waves. So if I consider this point as a primary sources of light, and this primary source of light is emitting wavefront, and this wavefront is indicated as primary wavefront because it is obtained from primary source. So this is behaving as the primary source of light. And as we obtain this wavefront, according to Huygens principle, we can consider points on this wavefront. Like this is 1, 2, and 3. Now, as we are aware, this is nothing but the source of light. So even on this primary wavefront, all the points are nothing but going to act as a source of light. But these sources are nothing but the sources present on the primary wavefront. That is why they are called as secondary sources. And secondary sources are going to emit light waves in all the direction. So I have a light wave moving in all the direction with the speed c, and they travel for time t. So all the waves which are getting emitted from that one particular secondary source is traveling with the speed c, and in time t they are going to all cover equal distance. And if I just take locus of all the points till they have reached, it is going to form a spherical wavefront. So once I consider the locus of all the points which is obtained by the waves, that as you can see, this is the source, that is secondary source. It is emitting light waves in all the direction, and all the light waves which are getting emitted will travel for time t and with the speed c. So they are covering equal distance. So if they cover equal distance, they are going to reach a certain points simultaneously. And if I take the points which I obtain, if I take that locus of all the points together, it is going to form a wavefront. In a similar manner, suppose if I consider the waves traveling or getting emitted from this particular sources, again they are traveling with speed c for time t. So again the distance traveled by all the waves are going to be same and they are going to reach all the points simultaneously. And once I take the locus of all the points together, which are in same phase because they are reaching the points simultaneously, that locus of points is giving me wavefront. Now if I just take a tangent to this point, we can just join the tangents together and we are going to get a new wavefront, and this is indicated as secondary wavefront because the secondary wavefronts are obtained from secondary sources. So in this manner, whether I consider a primary source of light or whether I consider secondary sources of light, we can draw wavefront using the Huygens principle. And obviously wavefront is nothing but locus of all the points together which are in same phase. So if I consider locus of all the points together, these are going to give me the origination of wavefront. So that's all about the wavefront and the Huygens principle. Thank you so much.